So good morning students. Here we are with our new video which is on anode cooling methods. I know that it's been already many days that I didn't upload any content, like 3-4 days. So I'm just uploading this because it is a kind of very important topic for your exam. I know that you have your exam today. So all the very best. Give your best. Let's go do the rest. Okay. So let's start this video. So tell me one thing, that did you know that in X-ray production about 99.9% of energy is converted into heat and only 0.1% into useful X-rays? Yes, you already know. I've already explained in the class. So if we don't cool the anode properly, the X-ray tube can get damaged. It's very obvious. So let's understand that how cooling methods actually work. Okay. First, let's build a concept on why cooling is needed. Why do we need the cooling? So when high speed electrons hit the anode, most energy converted into heat and very little become X-rays. And this large amount of heat can damage the anode, reduce the tube life and affect the image quality. How? We'll see that. So cooling is not an option, okay? It is essential. Then let's start with the first method, which is self-cooling or natural convection. How do it work? Here heat is removed by natural air circulation. We circulate the natural air inside the tube and the heat is get removed with the help of method which is known as convection. No fan or external system is needed. Okay, mark this word, that no fan and no external system is used. Now the question is, where do we use this method? So we can use this method in low power X-ray machines like dental machines. Okay. Simple system, but here cooling is very slow, so we can't use this in very high power machines like CT, etc. Okay, we can't use this method there. Second is forced air cooling or air blower system. I have already mentioned everything related to your notes in this diagram. Go through this diagram and you can attempt your exam. So forced cooling or forced air cooling. Now we move to a more efficient method, which is obviously forced cooling method. So how do it work first? Here we do use a fan or a blower that pushes the air over the anode. Okay, here we push the air with the help of a fan or blower, and here heat is removed faster than natural convection. As compared to natural convection, not very faster. Okay, here heat is removed faster according to or as compared to natural convection, but not very fast as compared to other methods. Now the question is, where do we use this? We do use this in medium power X-ray machines like general radiography, CR and DR X-ray machines. Okay, more airflow means faster cooling. Next we have another method which is very efficient, and the name is oil immersion cooling or oil bath system. How do it work? Here anode is immersed in oil. As the name suggests, oil immersion. So here anode is immersed in oil and oil is going to absorb the heat and carries it away through the molybdenum stand that we have already studied. Now the question is, where do we use this? We do use this in high power machines like CT scan, fluoroscopy. Okay, so oil cooling is the most efficient one, faster heat removal, but the natural convection is the least efficient one and forced air cooling is the medium one. Okay, we have three methods which we used in radiology for the anode cooling. So if we want to compare natural convection, slow cooling, forced air, moderate cooling, oil immersion, fastest cooling. Better cooling allows higher MA, means you can use more larger exposures like kVp and MA, longer exposures, and which improves the better image quality. Efficient cooling is going to provide the longer tube life along with the better performance of the tube. So this is all about anode cooling method. I hope you understand the topic. Please go through the notes which I have already mentioned in the image and you are ready for your exam. All the very best for your exam. Give your best. Thank you.